Molar mass. So you have just learned how to convert 1 mole into the number of atoms, formula units, or molecules. Now, it is really, really hard for scientists to count the number of atoms and use that to do chemical experiments. The only way that you could measure is using a scale or a balance and to figure out mass. So the only thing that we have in our lab is a scale. So how do we use mass and relate that to moles? So this is what you are going to do. First of all, you need to know the difference between mass and weight. Mass is the amount of matter in a substance. So the amount of mass for any substance is the same on Earth as it is anywhere else in the universe, where weight changes because it is the force of gravity on that object. The units for mass is kilograms, and the unit for weight is Newton. And so you would use Newton in physics, where you would look at vectors or the force of gravity. So mass is always constant, where weight can vary. So scientists don't want to go through all the trouble of counting atoms. So we take the atom or the formula mass and use that to figure out the number of moles. So atomic mass is the mass of one atom of an element. So the mass of carbon is 12 atomic mass units. And molecular mass is the mass of one molecule. Example, the mass of carbon dioxide is 12 atomic mass units plus 2 times 16 atomic mass units of oxygen. So the 12 comes from your periodic table, and you'll see the atomic mass unit for carbon is 12, and the atomic mass unit for oxygen is 16, and times that by 2 because in the molecule there are 2 oxygens for every 1 carbon. So its atomic mass is 44. Now, how are we going to relate that to grams? So 1 mole of atoms of any element, we know that there will be 6.02 times 10 to the 23 atoms. And it also has a mass in grams. Now, the mass in grams is equal to the atomic mass in atomic mass units. So what does that mean? That means that 1 carbon atom is 12 atomic mass units, which is also 1 mole of carbon atoms equals 12 grams. So molar mass is the mass of 1 mole of a substance expressed in grams per mole. So carbon has a molar mass of 12 grams for every mole. So in 12 grams of carbon, there is 6.02 times 10 to the 24 particles. And we're going to relate those in a later lesson. So the molar mass of a compound is simply the addition of the molar masses of each element. So you're going to take, for example, if you have calcium chloride, you're going to take calcium and you're going to take its molar mass, which is 40.08 grams per mole. So see how that your atomic mass unit now changes from AMU to grams for every mole. Same with chlorine, but chlorine you have to times by 2. So your total is 110.98 grams per mole. So how are we going to use unit conversions? So this is what you're going to do. For every 1 mole, you have a mass in grams. And that is where you're going to find the mass in grams in your periodic table, which we only used in the past to talk about isotopic abundance, but now it becomes very important because every atomic mass unit is related to the 1 mole of that substance. So we can write it just like we did yesterday. You can rewrite the conversion factor as such. For every 1 mole, it's mass in grams, or mass in grams for every 1 mole. So both of these are just like multiplying by 1 because you're using the same amount, just different units. You're always going to use the one that allows you to cancel out the unit. So you're going to grab your sheet out, and I want you to add mass as your second circle. So in order to go from mass to moles, you want to have mass, and the other way, you want to have moles at the top and mass at the bottom, because you want to cancel out the mass. You want to have mole as your unit. And here, if you want to go from moles to mass, you're going to use cancel out mass, and then or moles, and then you'll have mass as your final unit. So let's work on an example. So you will have 2 moles of calcium. So this is what you're given, 2 moles of calcium, and you want it in grams. We want to know, calculate the mass in grams of 2 moles of calcium. So my conversion factor is moles to mass. So I start off by writing what I have, so 2.0 mole of calcium. So this is how you write it all out. Don't just write numbers, please. You have to write the units, otherwise you are not giving any credibility to this number. I don't know what you mean. So make sure you write your units down. Times it by. Now you want to get rid of this mole. You don't want the mole anymore. You want to convert it to mass, because it's asking you to calculate the mass in grams. My only relationship is moles to mass. So first you're going to write in 1 mole of calcium, you have 40.08 grams of calcium. So take a look at your periodic table. This is the molar mass for calcium. Okay, so cancel out your moles, and you are left with 80 grams of calcium. Let's take a look at another calculation. So calculate the amount of gold in moles in 275.8 gram nugget of pure gold. So you are given the mass, so 275.8 grams of gold. You want the number of moles. So and your conversion factor is you want to go from the mass to the moles. So let's start with what you have. So 275.8 grams of gold times it by the atomic mass unit, because here I want to cancel out my mass, so the mass goes on the bottom and the moles will go on the top, because I want to convert it to moles. And now I have 1.4 moles of gold. So that is it for this lesson. We will work on worksheet 3 tomorrow in class.